Hello everyone, welcome to the physics class. Today is 26th of September and today we'll be doing physics. In the physics we were discussing the chapter that is current electricity, and today we are going to do the last section from this chapter, that is the electrical energy and the electrical power. So these are the two topics, and here we will be mostly focusing on the expression of these two terms, that is energy and the power, and we will be finding the formula and we will be solving some of the numericals from the exercise. We all know that electrical energy exists in the nature in different forms. And we have also studied in the previous class, right, from class 7, class 6 onwards, we have been learning that is the conservation of the energy. According to the law of the conservation of energy, energy can be transferred from one form into another, but it cannot be created nor it can be destroyed. Like, while we have got different forms of energy, starting from electrical energy, we have light energy, we have sound energy, heat energy, we have these so many other types of energies like mechanical energy, etc. Electrical energy, if you take that, there are many what you call instances. You can also see in your textbook, it is in page number 207 or 208. There you will find some of the examples where this electrical energy is converted into different forms of energy. Like, for example, if I give one example, how this electrical energy is converted into a sound energy in case of a microphone and a loudspeaker. We use a microphone to speak, okay, that means especially in a public function, and there is a loudspeaker. So when you are speaking, your sound, it will be entering the microphone in the form of the electrical pulses, like an electrical wire or the charges. That electrical energy will transfer it, and it will come out in the loudspeaker in the form of sound energy. So that is one example where electrical energy is converted into sound energy. That means one form into another form. Likewise, there are so many other examples. You can go through your textbook, you will find around 8 to 10 examples. Please go through that. Now, today we will be discussing on expression of this electrical energy. So basically we are going to find the formula for this electrical energy. We have been learning that in a circuit you have a source of current. Basically it is a cell, and it has got a positive terminal. Let us say there is a resistance, okay, and there is a key. The current I is flowing here. You have a potential difference V, and you have a resistance here, and this is a plug key. This is a basic circuit diagram. It is a closed circuit diagram, and you have the current flowing in it. So what happens here is you have to go to the formula of the potential difference. If you recall that the potential difference is defined as the work done in carrying a positive test charge from one end to the other end. So it is given something like this. Yes or no? So now from here we can write in terms of work done V into Q. Or we also know that the charge is if you look at this current is the rate of flow of charge, how much charge is flowing in a given time, and from the formula of the charge we know that it is I into T. Okay, so here this work done, whatever work is being done, that work done is conserved as the energy. That it is energy in this electrical circuit. So electrical energy is described as the work done. So we can write this work done as the energy, and the formula of the energy is given as V into I into T. So this will be your expression for the energy. Alright, electrical energy. Because here we have this electricity, that we have the current that is coming out from the source. So electrical energy is expressed as V into I into T, and there are some more expression, okay, other expressions of electrical energy as well. So this is one of the first formula. Let me do the second or the other formula. If you recall that we have learned so many other formulas. Now if you go to the Ohm's law, alright, see, Ohm's law says that V equals to I into R. So we have other expressions. We have the other expressions for this electrical energy. The first expression we got just now, V into I into T. Second expression, we can replace the value of V from the Ohm's law. So if you substitute your V, what you will get? V I into R. If you now multiply, you will get the second expression, I square R into T. So this will be your second expression. In the second expression, this electrical energy is expressed or written in terms of the resistance, the current, and the time. So there is no potential difference here. Likewise, you also have the third expression for this energy, electrical energy. Now we can express in terms of the potential difference and the current. Suppose now you want to replace the current. So from the Ohm's law only, you take the help of Ohm's law. I will be V upon R. So what do you get here? So in place of I, you replace that. Okay, so I is replaced. This is the basic expression. With the help of this Ohm's law only, we can find different expressions for the electrical energy. So V square, R, 1 R cancels, so 1 R will be the denominator into time. So these are the three expressions for the electrical energy. So electrical energy basically can be written like this. VIT equals to I square R into T equals to V square T by R. So these are the three formulas that you have to keep in mind, and remember you will be getting some simple numericals based on these three formulas. Now another topic will be the SI unit of the electrical energy. Electrical energy, we know it is same as the work done, and the SI unit of work done is joule. Therefore the electrical energy also has the unit joule. So SI unit of electrical energy is joule, which is given as capital J. So basically this is what we need to understand in the electrical energy. We have given the expression for the electrical energy in the circuit when you have a current flowing through the potential difference across the end of the cell. Now the second term which is there in this chapter is the electrical power. So you have electrical power now. Electrical power, it is defined as the rate at which the electrical energy is supplied by the source. At what rate the electrical energy is supplied. So it is the rate of supply of the electrical energy by the source. Source basically is the cell. So electrical power is defined as the energy supplied by the source upon the time. Energy, the rate is always, it is expressed in terms of time. So electrical power is given by P, energy supplied is given by E, and the time is given by small t. So energy, we have just found the formula for the energy in the just previous section, previous topic. Electrical energy, the first expression is V into I into T. Yes or no? So therefore, we find that power T and T will cancel. It will be V into I. So this is your expression for the electrical power. That means the potential difference into the current flowing through the circuit. Okay. Now you also have the other expressions for the electrical power by using the help of the Ohm's law. So you have got the other expressions. Other expressions for the power. Let us take the power. Suppose if you replace the value of V from the Ohm's law, V is equals to I into R. Yes or no? So therefore, if you replace that, you will get IR into I. So the second expression will be I square into R. This is the second expression for the power. Likewise, you can also find the third expression for the power. V I. Suppose if you replace the I from the Ohm's law, V upon R, because basically you have to use the Ohm's law as the base or the foundation in order to find different expressions for the electrical power and the electrical energy. So now the third expression is V squared by R. So therefore we have got three expressions for the power. V into I is the first expression. Second is I squared into R, and the third is V squared by R. Okay, so these are the three expressions for the electrical power, and we already know that the unit of the electrical energy is electrical power is, if you look at the first formula, it is energy, that means it is joule. Time is second, so it is joule per second. But this joule per second is also written as watt. W-A-T-T, watt. So therefore, the SI unit of electric power is watt. Now, there will be a question asked. It was asked in ICSE. Define watt. W-A-T-T, watt. So 1 watt is the electrical power. So we define 1 watt is the electrical power consumed when a current of 1 ampere flows through the circuit of the potential difference of 1 ampere. When you have a 1 ampere current, it is flowing through the potential difference of 1 volt in a circuit. So whatever is the power consumed, that power will be the watt. Okay, so these are the three formulas which you have to keep in mind for the electrical power. Likewise, you also have to keep the three formulas in mind for the electrical energy. Now the most important, the next topic is the commercial unit of electrical energy. Commercial unit of electrical energy. How the electrical energy, like for example in our household, we have got different electrical appliances which are used on a day-to-day basis over a period of time. So what are all those appliances doing? Basically, if you take, for example, you have a refrigerator, you have got AC, you have got iron to press clothes, you have got so many other mixer grinder, etc., etc. So all these electrical appliances, when they are in use, they are consuming the electrical power, and that electrical power you have to pay the bill, the money, to the electrical company or to the power department. All right, so that electrical energy which is consumed by these appliances are measured in a unit, and that unit is known as the commercial unit of electrical energy. So the next topic will be the commercial unit of electrical energy. All this electrical energy is consumed by these appliances which are in use, in very much use in our day-to-day life on a daily basis. Alright, so we have just learned that the power is energy by time, or we can also write down energy as power into time. You can cross product this. Sorry, the pen dropped. So power into time, PT. Alright, so now here this time will be expressed in terms of hour, because we cannot use the time in second. So these appliances will be consumed over a period of time, and that time is taken in terms of hour. So therefore the unit of the power is watt, the unit of the time is hour. So therefore watt hour is the commercial unit of the electrical energy. But since the appliances that is consuming the electrical power, it is expressed in terms of the bigger unit of the power, that is we usually express as kilowatt hour. So kilowatt hour is basically the commercial unit of the electrical energy. So this is a kilowatt, and you know that a kilowatt is 10 to the power 3, and this is the hour. So this kilowatt hour, it is known as 1 unit. Like for example, if you have the appliance, any electrical appliance, let us take one washing machine, okay, and it is now connected to a source of current. So suppose this is now in use, or it is running for 1 hour, time is 1 hour, and the power that is consumed by this washing machine is, let us say, 1 kilowatt. So it has consumed 1 kilowatt power in 1 hour time. So if you multiply, you will get what is the power, what is the energy consumed? 1 kilowatt hour. So this 1 kilowatt hour is known as the unit. Now all of you have seen that at the entrance of your house, or just outside your main door, you will see this electrical board is set up, and there one of the device is the electric meter. What is the work or the function of this electric meter? This electric meter is used to measure the amount of the energy that is consumed by the various electrical appliances which are used inside the house over a period of time, so that whenever it is consuming, we express as 1 unit, and 1 unit is basically 1 kilowatt hour, and 1 kilowatt hour is basically the unit of this electrical energy. So we say that if it is the money that which you have to pay the cost, that cost is measured in terms of 1 unit. Suppose you have consumed 5 units. Suppose this washing machine has consumed 5 units of the, it will cost 5 unit. 5 unit means 5 kilowatt hour. That means you have to pay in terms of the unit. There will be a rate. We have a different rate for the domestic users and for the commercial users. Okay, nowadays if you look at for the domestic rate, it is around 5 rupees per unit. So you have to pay 5 rupees per unit. If your appliances is consuming 5 unit, then you have to pay 5 into 5, that means rupees 25 to the power department. Okay, so this is all you need to know. The commercial unit of the electrical energy is measured at kilowatt hour. Time is always expressed in hour. The formula of this power is energy by time, and the energy for the commercial purpose is used as power into time. Okay, so we have discussed so many formulas here. So all these formulas you have to learn it by heart, and you have to write it down, maybe in a piece of chart paper. You can just make it, and these formulas will be used in order to solve your numerical problems. Okay, now before we start the exercises, let us do one final topic from this chapter, that is heating effect of a current. So whenever the current is flowing through a circuit, okay, which has a potential difference V, that current, heating effect of current. So whenever a current is flowing through a coil, okay, it is connected to a source. That means if the current is passing through a coil, it will also produce the heat. There will be heating effect. So this heating effect, the amount of heat in a wire on passing the current, it depends upon three factors. So it depends upon three factors. First is the amount of heat. The heat, whatever heat is produced, it depends upon the current. Basically, the current flowing. How it is dependent. The heat, whichever heat, the amount of heat produced will be directly proportional to the square of the current flowing through the wire. So if you have more current flowing, the heat produced will be more. Second is, it depends upon the resistance of a wire or a coil. This Q. In this case, okay, Q might be confusing with a charge, so let us write down the heat as H. It is directly proportional to the resistance of a wire. So if the resistance of a wire is more, then the amount of heat produced will also be more, directly proportional. And the third factor, it depends upon the time. If you flow the current for a longer period of time, the amount of heat will be directly proportional to the time. More the time you are flowing the current, more the heat will be produced. So if you look at this, these are the three factors. If you combine all the three factors, we get that heat is equals to I square R into T. This is the energy. If you remember at the beginning, the formula of the energy is also given somewhat like this. Like that energy which is produced due to the flowing of the current can be also converted into a heat energy. Alright, so now this is the end of the chapters. So in these chapters we have discussed many other things. So in the next class we will be doing some of the exercises from page number 211. Please turn to page number 211. There is exercise 8C. You have to do the questions from 1 to 16. I will be sending you one PDF format where everything will be solved, and after that there are some of the numericals which you have to solve it. So for the numericals, all the formulas that we have learned so far from this chapter will be used. Okay then, we will see in the next class. Thank you very much.